All right, so I have the honor to have almost the last speech of Hack in the Box. This was my first Hack in the Box, and I liked it very much so far, and I think I'll join in the future as well. So, welcome to my talk. I'm a senior threat researcher with Trend Micro Research. Before that, I spent 10 years of my life in academia. So I've learned a good deal of machine learning way before it became like a hyped tool. So I've been doing machine learning and anomaly detection like 7 years ago. So before the industry started to understand the value of this. And I'm very happy that when I joined Trend Micro, I was able to apply the same techniques that I was using during my PhD for completely different purposes. So today, I'm going to talk about how we can apply some machine learning tools to analyze large corpuses of web pages to make sense of them. So here we are in the area of investigation tools, so tools that can be used by law enforcement or hunters to understand, to make sense of very large data sets of defaced web pages, to understand, for example, how the attackers are organized, what kind of targets they go after, and so on and so forth. So before I start, I would like to briefly introduce what we mean, what is web defacement. Web defacement has to do with a compromised website. So it all starts with a bad guy that either compromises a website or purchases access to a compromised website in the black market, for example. And then we have the alteration part. So the goal of the bad guy here is to post some arbitrary content on a website, on the homepage of a website that he or she has control on. And of course, the interest is to put that content on the homepage so everyone can see it. Okay? And the highest the profile of the website is, the better is from the attacker's standpoint, because the message will be seen by more and more people. Several people I talked to perceive web defacement as a thing of the past, something that, script kiddies and people who just play around with web hacking and just post offensive content on the web. But it's actually different. It's a real thing. And as you can see from this news, a very famous defacer was recently arrested in California for hacking more than 10,000 web pages, defacing more than 10,000 web pages. So these things are real. And I remember the nickname of the guy, Alfabeto Virtual, because before they arrested him, and I don't have anything to do with the arrest, but before they arrested him, I remember seeing the nickname of this guy popping up very frequently in our data set. And I've looked at something like 13 million defacement web pages. And I remember this name continuously popping up. So I was like, this guy is really into it. I mean, this guy is really defacing several web pages. There is interest, of course, in the detection part. So as a company, you want to be able to detect if your page has been defaced as fast as you can. In my opinion, even though I love Kevin, he's a great friend, he's made a very interesting piece of work here, I don't think the defacement, the detection part is very important. In the sense that, for a website operator, it's fairly easy to deploy integrity checks on the website and understand if the web page has been defaced or not. And also, it's in the interest of the bad guys to announce the defacement as loud as they can, so people go and see it, right? So detecting alone is not really something that I deem as important. By the way, this approach is actually quite cool because it uses deep learning on the screenshots of the pages to tell legitimate versus defaced web pages without previous knowledge. And it's actually quite cool because it can narrow down the logo of the defacement group or the logo of the hacking group that is running the defacement without any prior knowledge, right? So it's actually a quite cool approach. I'm more, and my colleagues that have worked with me in this project, we are more interested in what we can learn from the activity of these people. And by looking at these web pages, we've learned that there was a series of steps, evolutionary steps in this phenomenon. So starting from like the 90s, we could say that this was just a just for fun era where people would deface a website and post rather offensive messages directed to the administrator of the page to say, hey, your security is not very good, and that's why I was able to, I was able to hack into your website, and this is the proof that I've hacked your website. So what you can see here on the left is the, a classic message, and on the right you can also see that the guy is posting the UID equals 0 to, prove that he or she has got root on the machine. So it was more like a showing off kind of motivation. The second step is when these people have started to understand that, well, maybe we can use these pages to talk to the world, like to tell a message, right? So we call this a digital activism phase. In this area, in this phase, you could see messages such as this one, promoting freedom of speech. So I hack into this website because I live in a region where freedom of speech is not accepted, and so I use this illegal way to, make my voice loud. Okay, you can see several of this in this era. The third part is when around 2000, 2005, we've started to see attackers being influenced by external events, like real-world events. And I'm looking at geopolitical events like elections, conflicts, or death of key people. So events that usually shape the world. Okay? I'm not referring to any particular events, but you can guess what kind of events we have in mind, right? So in this era, you could see pages like this example when Augusto Pinochet died was 2006, and you could see someone who was actually supportive of Pinochet hacking a website and saying, I was here, rest in peace, Pinochet. And you could actually find other groups that were instead against Pinochet who were posting similar defacement messages. So it was a way to, tell their opinions in an illegal way, right? The fourth part, the fourth step in this evolution is what we are witnessing now. We call it dark propaganda, because what the defacers have learned in the past is now being used as a sort of fake news spreading channel. So they're using defaced web pages also to influence opinions. They try to influence opinion by posting propaganda messages. And I call it dark propaganda because it's, of course, illegal to do that. So you could see, like, not just one web page, but several web pages being hacked by groups or several individuals to support or to, in this case, they were showing their attachment to Michael Jackson right after his death, right? Recently, you would see several of these pages supporting one event, right? So I think this is interesting. I mean, this was interesting for me and my colleagues when we started, but then we said, okay, how can we scale this? I mean, by looking at web pages, we could learn some of these things. By looking at the evolution, we could learn some of these things. So can we really scale it? Can we make it like a system that processes streams of millions and millions of defacement pages and help the investigators make sense of this data? Right? Maybe help the investigators say, okay, this group is always acting in a group and the other guy there is always acting alone. Okay? Questions like this would really help investigators and law enforcement. So first of all is what I anticipated at the beginning. It's in the interest of the attackers to post their mischief, so to tell the world what they just did. So what do? They hack into a website, they compromise it, and then they go in one of these repositories and post the URL, the metadata, their nickname, the reason why they wanted to hack that, to show off, to say, hey, I was the first to hack into this website. They have like incurable narcissism, right? And there are several of these public repositories. Like the previous one was mostly Chinese. Then we have Hack Mirror, Mirror Zone, MyDeface. What we actually used is what we call the website, run by the Zone H people, which is the most comprehensive one. We think that Zone H is actually doing mirroring of the previous one, so it's got the largest data set possible. So there are several of these, but at the end, we ended up using mostly Zone H. As you can see in this table, we're talking about something like 13 million web pages overall. So this is certainly interesting, a good starting point. By the way, if you have any questions during the talk, I'm okay, since, One of the first things that we can let's look at some general trends. You could see that defacement is an increasing phenomenon. Don't be misled by the last bar. This is because we purchased the data before the end of the year, so we don't have the full bar. But that's we want to show. All of the results that you see from now on are based on this data. So we don't want to lie and say that we have analyzed all of the data in 2016, because that's when we closed our snapshot of data, right? So let's look at the format. How is this data organized? We can divide it into two broad groups. At the bottom, you have the actual content. This is what the defacer plants into the site. Okay, so you have images, you have the raw HTML, you have the CSS files, JavaScript, even some malicious JavaScript, right? And then you have the metadata part. What you see at the top is not part of the defacement itself, is part of what the attacker posts on the website, like Zone H or Hack Mirror or whatever. So he or she would say, I was here on 24th I don't know, we had to hide that. And this is my nickname, and I hacked into this domain. This was the IP address, the system, I think it was Linux, web server Apache, and so on and so forth. And then what you see down there is the set of nicknames of the hackers that have broke into that website. That's just an example. So I want to spend a couple of words talking about data accuracy, right? So you can immediately understand that we have, in these two broad groups, what's most accurate is the actual content, right? The attackers cannot lie about the content, right? It has no interest in planting content that does not matches the end, does not matches the motivation of the attacker. So we can trust the defacement part, the raw content in green, you can trust it a lot. So images, embedded resources, external resources, those you can trust them. You can be sure that that data has high trustworthiness. It's what the attacker meant to plant in there. The other part, the metadata, you have to be careful, because, there might be, nickname might not be accurate. The attacker may lie about the web server, or may lie about the reason why he or she wanted to hack into that website, just to, cover up the traces a little bit, to make it, show off, but not so much. So, with respect to previous analysis approaches in this space, we don't really trust the metadata. We don't want to trust the metadata. We look only at the defaced content itself. Okay? And that's why, going back to the first paper that I showed, the screenshot, the deep learning thing, that was very good because it was looking only at the screenshot, the raw screenshot of the page, so super accurate. So let's take a look at some general trend in this data set. Why was I able? I actually lied at the beginning. The timeline that you saw, I built it at the end, right? Why was I able to come up with those phases, with those 4 phases? Because I started to look at what these guys were discussing, what these guys were talking about in the defacement content that was planted. So what I did is I used a technique called topic modeling. It's a mixture between machine learning and natural language processing that allows you to elicitate interesting words, interesting keywords out of a corpus of text, right? So I did this on an annual basis. So every year I would take the snapshot of all the pages and run topic modeling and elicitate the 5 most important topics that were discussed, right? And one interesting thing caught my eye. And that's why I've drawn a line there. Before 2005, I've never seen a single word mentioning a real-world fact. Whereas in 2005, when Pope Francis was elected, you could see the word Pope popping up. And after that, you would see other words connected to the real world, like terror, Turkey, country, village, crew, terrorism, something that have to do with real events. Whereas in the past, you could only see something like, oh, this website is lame, there's a security issue, I was able to enter in this website, we are the coolest crew, we are the coolest group, keywords mostly referring to the poor security and to, self-celebration of the hacking group itself, right? Whereas from 2005 on, you could see that these people are actually humans. They were looking out in the real world for facts. Another interesting trend is the adoption of malicious content. We are Trend Micro. We have good data sets of malicious pages, so we know how to detect a malicious page or not. So what we did is we queried our systems to know whether at that particular time the face web page was malicious or not. Malicious was containing some malicious JavaScript or malicious client-side code. Okay, something that would harm the browser. At the beginning, you wouldn't see a lot, but you see an increased adoption of malicious web pages, and this could tell us 2 things. Either the defacers are the one who planned the malicious content as part of the defacement, or the defacers have started to purchase compromised web pages that were already malicious, and they were reusing them. We don't really know. We cannot tell, because we don't know where the page is coming from. Another interesting thing is that, well, the attacker seems to be catching up with new communication technology. So if in the past they were using mostly emails, now you could see that emails is, not being used a lot, and they use several Twitter handlers or Facebook handlers to post on the content of the page. So in the past you would see, hey, we are hacking group 123, and this is our email address if you want to get in touch with us. Now you see, hey, we are hacker group 123, and here's our Twitter handler or Facebook handler or my chat handler, whatever. So let's now drill down and let's go from general trends to key observation. What are some key observations that can help us design a fully automated system to query and understand something about these people? Here you can see 2 pages that I had to blur out a little bit because I didn't want to reveal the hacking group behind it. But you could see at the very bottom 2 different, well, it's also obscure, but still, you could see a very similar page, right? But you could see a different list of hacking names or hacking groups, right? This is interesting because it shows that attackers do not always act alone. They group up and they like to show off the mischief of the group. Another interesting, starting from this, another interesting observation is that if you look at these two web pages, you can tell immediately that one is derived by the other one. So the one on the left looks more like a template. You say, why do you think the left one is a template and not the other way around? Well, because if you look at the team name at the top, you see it's anonymous. So our guess is that this template has been, introduced or used heavily by Anonymous, and the guy on the right has taken that page, that template from Anonymous, and used it to to show off what he did on other web page. Right? We think that maybe the guy is using that same web page to show affiliation to Anonymous, or maybe to show appreciation to what Anonymous was doing. There might be multiple reasons. But we've seen this, this interesting fact. So to summarize, we can say that the facers hack in groups. Defacements are organized into campaigns. We don't see, sporadic defacement anymore. We see coordinated campaigns to hack into a specific group of websites, not just one website, posting the same message or variation of the same message with slightly modified templates, right? So how can we go from these key observations to create what we call Defacement Explorer, the next generation of Defacement Explorer? At Black Hat Arsenal last year, we presented DefPlorex, first generation Defacement Explorer, which is a set of tools that we released partially open source to dig into this data. Right? With this new observation now, we are introducing a next generation of it. So let's take a look at the workflow. We start from the defacement web pages. We have this large data set. We do some very lightweight deduplication. And for that, we use fuzzy hashing just to make sure that we're not looking at the very, very, very same web page, a very light deduplication. We keep track of the duplicates so that we can go back and obtain the expanded set of duplicates when we want to look at how many of the same page have been posted around. We pass all of these pages into two analysis pipelines. One is static, which means that we simply grab the source code and the resources as they are. And also dynamically, because you know that if you render a web page, clearly the way it's displayed can be very different, can mean very different source codes, right? So we wait until the page renders completely in an instrumented browser, and then we capture the DOM, essentially, of the page, and all of the other resources dynamically at runtime. Then we run what's most important, that is the campaign detection. So first we pass all of these pages into a feature extraction. This is essentially in every data mining or machine learning pipeline. You extract features from the pages. You represent basically your objects as a series of numbers. And then you run a clustering step that will allow you, we will see in the next slides, it allows you to find groups of related pages. Okay? And then we expand the clusters. We reduplicate the pages using the duplication index, and we expand the clusters to contain all of the original pages. At the end of the pipeline, since this is meant to be a tool for exploration, for manual analysis of large corpuses, we have a nice web interface where the operator can just query for keywords or modify how the clustering happens or choose only some features for the clustering, all at runtime. So the web, I can give you a demo if you want, if you come by after my talk. I can show you a demo of the web interface. But what you have is essentially a pre-filtering search. We're using Elasticsearch as a backend. So you can use the same Elasticsearch syntax to run your query with time ranges and everything that Elasticsearch supports. We are in the cluster phase here. And then if you want, once you have decided that, okay, I want to cluster only the pages that contain the keywords deep water horizon, and then you can maybe refine your search after the clustering. So you can say, I want to have all the clusters that have a time span of 1 year, or all the clusters that only last, 10 days, and I want clusters that are as large as 2 or more pages. Something like this. What you see at the bottom here are the members, the groups of the cluster. So you could see there's one cluster with 72 pages, the second cluster with 56 pages, and then 43, and so on. And the colored things that you see right there are an expression of the features. So if you hover over those, battery-like icons, it will tell you what feature, and we will see the features in a bit. You will see what value the feature has. So the color coding here helps having an understanding by just looking at how the cluster is organized. So if you see all green, it means that all of the values of the features are low. If you see red, it means that that feature has a very high value, right? So the idea is that you want to group pages that have similar values of all the features. That's pretty much the logic. And but we will return to the features later. What you see on the right is the timeline, and you can immediately see by just looking that, for example, the first cluster is probably a spike of activity, one campaign around a couple of days, whereas the second cluster is a campaign that has been lasting for months or years, spread over a long period of time. And the same for the other ones are instead like the first one are spot campaigns. Okay? And you can, of course, scroll and hover, and you will have contextual information. So, for example, if you hover over the numbers, you could see the breakdown of the domains. If you hover over the TLD, you can see the breakdown of the TLDs. If you hover over the screenshot, you could see the screenshot of one of the pages expanded. So it's an interactive exploration tool. Right. So I hope I got you, enticed by now to be curious about what the implementation details are. So let's take a look at what are the internals of this tool. So as I said, key to every machine learning pipeline is feature engineering. So we have to find out a way to represent a page with a series of numbers. So we are compressing the space a lot. Of course, we are losing a lot of information, but that's essential because we want to be able to use math and clustering to make sense of this data. So this is what you see here is the result of our feature engineering. We isolate 4 groups of features, actually 5 groups of features. I couldn't see the yellow in this screen here. The format of the title, and when I say format, I mean the grammar of the title. So we would calculate, for example, how many, the distribution of each character family, so how many capital case letters there are versus how many lowercase, how many numbers, how many punctuations, and we do the fractions of all of this, and we represent this as a vector. So that vector of numbers is our title. We do the same with colors. So we cluster the colors. We find the top 5 most popular color within the same page. And then we keep the histogram, essentially, of those colors, the RGB histogram of that color. And you get numbers again. I cannot read from there, and I don't remember what's that. Visual features, images. We keep track of how many images they post. If these images are external or embedded. Right? We keep numbers, number of external, internal images. Social features, how many Twitter handler, how many Facebook handlers, how many Twitter hashtags, any social feature that you can think of, we have a number for that. And then we would like to represent how the template is structured. So we would like to say, oh, this is how the HTML looks like. But of course we cannot, because it's very hard to represent a tree as numbers easily, right? So what we do is we keep track of how many of each HTML tag they have. And we get rid of the, the silly styling tags such as font or strong or, slanted letters and stuff like that. We only keep the structural elements such as div, table, and stuff like that. We also, keep track of email addresses and all the URLs. Here you see a page that, stands out for the amount of URLs that these guys have planted as part of the defacement. This is an extreme case, just to make the point. We keep track of how many URLs they insert. So to summarize, here is how we encode all of our features. We have the group of visual features, number of images, the perceptual hash of all the images, the perceptual hash of the screenshot, the average colors. We keep a float, 3 floats, RGB. The type of the first sound URL. This is interesting. I think it's interesting because we found out that these guys use embedded sounds, or they embed like YouTube medias, or they embed SoundCloud media in the defacement web pages. So when you land on these defaced pages, you would hear like a patriotic music or something like that, right? So I think that that's interesting to characterize what's the ideology of the group or what the group is doing. So we keep track, for example, how many YouTube URLs there are, how many external URLs there are of, media type, or how many embedded media object there are, because that characterizes what's the, the tactic of the group. Do they use external? Do they use internal? Number of each tag. Geographical feature, we keep track of the encoding. Like, is it mostly like Chinese? Is it mostly like Cyrillic? Is it mostly Latin, right? Social and title I've already spoken about. One thing I want to clarify is that, as you may have noticed, there are some categorical features. Most of them are numeric, which means you can use them straight into your machine learning pipeline. Some of them are categorical. So how do you convert them into numbers? You enumerate all of them. Let's say that you have 4 categories for each category. You make an array. You say category 1, 2, 3, 4, and you convert them to one using one hot encoding, which means you put a 1 exactly when the category matches, and all the rest is 0. Right? You usually want to keep these categorical features as at the minimum. Like, you don't want to have many of them. And you want to keep the number of categories as low as possible, because it's very easy to explode the number of features if you had too many categorical features with many categories. Speaking of now we have a set of features, now we want to cluster them. We want to organize the pages around a metric using the features that we've just extracted. So for clustering, we wanted something that was very, very efficient, nice with respect to memory and computation. We've started with dbScan, but didn't work out pretty good. It didn't scale very well. If you take a look at this graph, that monitor is not really good, but this one is fairly good. You could see that, in solid gray, that's Birch. That's the, amount of memory and amount of computation that Birch requires by number of records that you cluster. And you could see that it grows very, very slowly. Instead, if you use dbScan, woof, goes out immediately. You need lots of memory with dbScan. That's because dbScan needs to materialize all of the distance metrics in memory at once. Instead, Birch is hierarchical, and it doesn't maintain distances between all the points. It maintains statistics between aggregated clusters, so to speak. I'm oversimplifying. But the idea here is that it doesn't need to keep all the data in memory at once. So if you have large data sets, give Birch a try. It's been ported to scikit-learn and all the major user-friendly machine learning pipeline. It's very good. It's very efficient. Right. So now we have the cluster. But, you have a big number of pages. You look at them and you say, okay, what's this? Everything is opaque. It's pretty much like when you use deep learning deep learning can magically make sense of data. No, it doesn't. Deep learning can magically find features that it doesn't have any idea what the features are, group objects or classify objects with respect to those features, and it tells you, okay, object 1, object 2. But you have no clue of what the model is about. It's hidden in the network. And the biggest you make the network, the hardest it is to make sense of the data. So it's completely opaque. With clustering, you have a similar problem, not so hard to solve. With clustering, it's easier to solve if you find a way to represent your data in a compact way. All right? So you could give a name, like a meaningful name to each cluster. You can say, oh, that's the cluster of Hope France. That's the cluster of, I don't know, the campaign for Michael Jackson. That's the cluster to protest against, I don't know what. Okay? If you're able to do that, you're really helping the investigator say, oh, that web page that I thought was an isolated incident is actually part of a campaign, and I can give a name to that campaign. I can tell who are the guys behind that campaign. I can somehow tell what language they speak, what they wanted to say, without even looking at the pages. Okay, that's the difference between pure clustering and making sense out of clustering, what we call campaigns. So we would give names to within the same clusters, and if we find by accident that two clusters end up having the very same label, we group those clusters together. So we do a second step of, coarser-grained clustering. So what we look at are the time span, so how long it is. So we can say, oh, this cluster is like one campaign that lasted 2 days. The thumbnails of the screenshots. We keep the perceptual hash. We look if by accident two clusters that ended up to be separate had the same perceptual hash. We try to extract the the name of the actors and the names of the team. We have a series of parsers which try to extract like lists of names. They use weird characters somehow, so it's not 100% accurate, but it's a good educated guess. Keywords used in the campaigns. Several groups use a hashtag and then the name of the campaign. Category of targets. This helps us understanding, for example, if the group is interested in governmental website only, or a business website, or minor website we don't really care about. This is how one of these labeling looks like. We have, cluster 4 with, that's the distribution of colors. You can see it's mostly black and white. We have also some red. The page is way larger. That's why red is not that popular as you may think. And also web pages that are not exactly the same web page, but they relate to each other, right? So it's not just let's group the pages by screenshot, or let's group the pages by color. It's a bit more complicated than that. And then again, we use topic modeling to, elicitate some keywords that might have nothing or not a lot in common with what you see written down in the pages, right? We try to make sense of all of the topics, right? Okay, so the last part of my talks will make a walk through some of the interesting cases that we think make sense to present to an audience. Whoops, little spoiler. So one thing that we could learn by looking at this data is how the actors are organized. We can tell, for example, that 43% of the actors are at least in one team. So just statistically speaking, we can query our clustering, our campaigns, and say how many of them are lone wolves, how many of them are instead in a team. So we can ask these kind of things. Or for example, we can tell that half of them would join campaigns that are larger than 3. Or that 70% of the campaigns are not by lone wolves, are by group of actors. Like, all of these things, if you look at them, like, written down, they kind of make sense, right? but we didn't have evidence so far. We didn't have the means to query a data set and say how many of these groups are collaborative, how many of these campaigns are collaborative, right? Now we can. What I think is if I was asked to choose an image out of the paper that we published that best represents the current situation of defacement, I would choose this image. We've drawn this image by trying to make a parallel between real-world events and campaigns. So from our tool, we found campaigns. And those campaigns were represented by those significant screenshots. And by looking at the timeline of these campaigns, and by looking at the timeline, we use Wikipedia, using the timeline of, strong events that sort of shook the world, you could see a very interesting parallel. So I had to obscure some of them because I didn't want to sound offensive or biased. But like, for example, the election of President Juncker was only one page, was not really a campaign, but that was very interesting to find a match. That the website of his party was defaced the day he was elected to protest against these elections. After the Charlie Hebdo shooting, there were lots of campaigns. When President Trump was elected, lots of campaigns again. They're even sensitive to, Deepwater Horizon oil spill. So events that might change, like the quality of life in certain areas. I think this is the most significant image of the whole research. Just to give you an example, Charlie Hebdo case, you could see an example of a page that says, "Je ne suis pas Charlie." I don't speak French. I wish my colleague were here because he knows how to translate this properly. But this saying that we are here to protect our Prophet Muhammad, Ob France, Ob Charlie, remember the name Dr. Hem, right? So what's interesting is that now that we have all of these clusters and campaigns is that we can look at them. We can explore them. So from now on, I'm going to use 3 symbols to visualize campaigns as a little square, the teams as a black diamond, and the actors as a, white circle. So we can tell something like this. Unfortunately, the screen is not rendering the arrows, but I swear there are errors. So you can say, for example, okay, Op Charlie and Contre Charlie, which are 2 opposite campaigns. You could see these guys, taking strong positions in favor or against the Charlie Hebdo shooting. And you could see how they were organized in teams. If you were looking at my monitor, you would see lots of arrows condensating into these 2 campaigns. This tells that and these were 2 very big campaigns. This tells us that in order to run these campaigns, actors have to team up, right? These are these are some of the biggest teams. And here you can say how they are teamed up. You can see the names, the nicknames of the attackers, how they are organized. Some of them, you could see errors going from here to here, and a bit of errors, not many, going from here to here, and just a very low number of errors going from here to here. This is telling us that independently from, the big campaigns, the big teams, there are some small aggregations, some small teams that try to participate, maybe to, get noticed or draw the attention of the big guys, right? To show their, appreciation and somehow contribute to the same campaign. And then there are some just lone wolves that do not really cooperate in any teams. Yeah, this is just, the anticipation of the previous slide. If you look at the targets, we could draw graphs like this. So I was told the other day by a journalist, what can you tell, for example, about a group? I can tell that Anonymous is after big government websites, right? A minority of websites hacked by Anonymous are like educational website, generically malicious website, restaurant website, not very interesting. But I can confirm that Anonymous is after like government, legal website, businesses, which kind of, matches the expectation of what you would expect from Anonymous. Another answer that we can give is there any difference between the length of the campaigns? Are they only short campaigns or long campaigns? We can draw graphs like this. What you see in the column right there is the nicknames of the attackers, nicknames of the campaigns. And you could differentiate between like short campaigns at the bottom, like very strong, aggressive campaigns in reaction to like an event like a war, a conflict, or something big. Or you could see groups and campaigns that organize and have like long-running campaigns that last like maybe years. And here you can even visualize. So if I'm asked, I want to see how the campaign Hackers Brazil look like. Boom, you get a timeline. You can see the various clusters, which are all, the black line at the top is the campaign, so how long the campaign is. And what you see is a kind of a cascade effect, right? So you see an initial campaign over there at the top, which targeted some website. And then another group of guys followed up with a related campaign, with a related set of clusters, still under the same campaign, and hacked other targets, and go on and go on and go on. So you can actually sort of see the clusters here, right? Just to confirm that we are aggregating things that make sense also in time. And if you drill down, like if you want to say, I want to see what's happening there, you can open up, you can zoom in, and you could see like one of the screenshots that is the most popular one within the cluster. Okay? So to conclude, I've spoken about how defacement evolved from a script kiddie phenomenon up to dark propaganda. Dark propaganda meaning using illegal means to promote messages, right? I'm not debating about the value of the message. I'm debating about the legitimacy of the act. It's a prevailing phenomenon. We've seen that it's increasing. And it's driven by real-world fact. We're not talking about, crazy people who just hack and deface, right? And we have seen that they go and target websites that match their ideology. Like Anonymous go after government websites. That makes sense, right? Now we have a confirmation. So if you're interested in this, we have an academic paper that describes in details how the machine learning pipeline works. We have a GitHub repository where we share part of the code. All of the code that we could share, we share it. And that's mainly about the visualization and clustering. And then we have more like an industry spin on the research, which is in that, long URL down there. So the slides will be published, so you'll be able to click on that link. So I would like to thank you to, attend this talk. And I also would like to thank my co-authors. One of them is there at the CTS booth. We'll be announcing the winner like in an hour or less. So make sure you're around, so you'll discover who was the winner of the RF hacking competition. And I'll open up the floor for questions, and I'll be here all night. I'll depart tomorrow morning, so feel free to just stop by and chat. I'm always happy to chat about machine learning and research, so anytime. Thank you.
Do we have any questions from the floor?
Yes, he has a question. He's been taking attention he's been, like this for the whole talk, so he has a question. I meant you, yes, he?
So you were talking about clusters. So yes. The nearest cluster, you can identify the new campaigns or something if something is going on. Mm-hmm. So I'll just give you an example. For example, there is a cluster of apples and cluster of oranges. Mm-hmm. So how you will identify in apple cluster, which is the rotten one?
So if I if I can rephrase the questions to make sure that I understand it. You're asking how do I put a label on the cluster? So
exactly.
how do I decide that, this cluster is op France?
Yes, exactly.
So let me go back to, I know it sounds a bit obscure the way I explained it because I didn't have enough time to dig into the details. So what's mostly interesting for us is the keywords that they use, right? The keywords we have, it's not science. It's very hard to extract keywords that are written into like variation of various alphabets using different characters, substituting, lead speech and stuff like that, all in a corpus of pages. So we try our best to normalize. We remove keywords that we think are not keywords. So we do some, black magic there. And we take the frequency of those keywords, and those who are most frequent are the representative of that campaign. But we have a set of labels, and that's what make our tool interactive. So we can say, I want to have all the clusters that relate to Op France, but I also want to have all the clusters that have this color, that is this perceptual hash. So we make it like a set of keywords that can be queried against, so that you can elicitate only the clusters you want. We don't say they're all apples or they're all oranges. Yeah. We say we give you the dimensions that you can decide how you want to classify them. You want to classify as fruit, you want to classify them as shape, right?
Okay. In this example, like of France, what if I give the 0 instead of O? So your algorithm will still work?
Yes, and what if that's actually the RGB color of the page, right? Yes. So again, we have a set of frequency-based pattern matching. We try to substitute some obvious characters. Like if we see 100% of, 99% of Op France and 1% of 0 France, then probably the same, right? So we do some distance metrics and stuff like that. Yeah.
Okay.
Yeah.
Cool.
Hey.
Yep.
So what I have understood till now from your talk is like you guys are parsing the HTML file and extracting all the keywords from that, and then feeding and extracting all the features out of it and feeding it to the machine learning models. But like I have personally seen cases where attackers are heavily obfuscating the HTML pages. So how you guys are handling those cases?
They do worse. They do worse than that.
That's the thing.
They lie on the encoding.
Yep.
So you would think that you could trust the declared encoding on the HTML. You would use that to decode the rest of the page, and it doesn't make sense. I mean, it crashes completely. Blob of nonsense, right? So that they go beyond that. We use both dynamic and static. That helps a bit. So we take the static HTML and we also execute the page. So we let it unroll, so to speak, and we take the results of that. And if we see that there is a lot of difference, like big page after the obfuscation, small page before the obfuscation, we take the largest one.
Okay, and like in cases of exploit kits, they obfuscate it heavily. Like it is sometimes not able, you are not able to parse it dynamically and decode it.
There were some cases in which we wouldn't be able to decode, but I would say that it's not really in the interest of these people to make the pages undetectable, because if you just take a screenshot, you would say it's defaced, right? So it's very easy to detect, right? So they don't really care about evading detection, right? They simply have weird ways that they create pages, right? Yeah. So I would say those are extreme cases that exist. We found them. But very, very little. Very, very few cases, yeah.
Okay, I presume that's all the questions we have. All right, thank you, Federico, for the talk.
Thank you very much,
Thanks, everyone, for
Hack in the Box.
attending.